everyone. Today I am presenting stack applications in data structure. Stack is a linear data structure in which elements are inserted and deleted from the same end called the top of the stack. It shows a last in first out behavior, means the element which will be inserted last will be deleted first or will be removed first. So stack finds in various applications in computer science and real world scenario due to their simplicity and efficiency. Several terms used in stacks are top. Top is the location where the last element is there. Push operation is used to insert any element into the stack. Pop operation is performed to delete any element from the stack. Peek extract the top element from the stack. Is full is used to check whether the stack is full or not. Is empty is used to check whether the stack is empty or not. Overflow, when stack is full, then this condition is called the overflow condition. Underflow, when the stack is not having any element, then this situation is called the stack is underflow. In this image we can see that the element which we want to push will be pushed from the top, and if we want to delete any element or pop any element from the stack, then it will be popped from the top. We have some common applications of stack data structure like function call and recursion. Sometimes we use functions in our program. So whenever a function is called, then the current state of the program will be stored in the stack. So stacks are used to manage function calls and their corresponding local variables and return addresses. When a function is called, its context is pushed onto the stack, and when the function returns, the context is popped, allowing for proper execution flow. Another application is expression evaluation. Stacks are used to evaluate arithmetic expressions including infix, postfix, and prefix notations. They help in converting expressions from one form to another and efficiently compute their results. Parsing is another application of stack. Compilers and interpreters use stacks to parse and evaluate programming language expressions. They ensure that the syntax of the code is valid and provide a way to keep track of nested structures. Undo redo functionality. So many applications are required undo and redo operations. So stacks are useful for implementing undo and redo operations in software applications. Each action is pushed onto the stack, and undoing a step involves popping the most recent action, and redoing it involves pushing it back onto the stack. Browser history. Web browsers utilize stacks to store the history of visited web pages. When a user goes back or forward in their browsing session, the browser pops the URL from the stack to navigate accordingly. Another application is memory management. Stacks are essential in managing memory in various programming languages. The call stack, which is a special type of stack that stores function call frames and local variables during program execution. Here we will discuss some applications of a stack like infix to postfix expression, evaluating postfix expression, and tower of Hanoi problem. Here we are converting or we are evaluating infix to postfix expression using stacks. First we will see the conversion from infix to postfix expression using a stack. So here we have taken an infix expression. So what we will do here is we scan all the symbols one by one in one column. Then we have a stack. In stack we put all the operators. Whenever we get operator, we push it onto it, and if some operand occur, then it will be pushed into the postfix expression. So these operators have some precedence, like plus and minus have similar precedence, multiplication and division have similar precedence, and bracket and power have highest precedence. So suppose similar precedence operator comes, then we put these operators onto the stack. Suppose we have lower precedence operator and some higher precedence operator occurred, then the higher precedence operator will be kept onto the stack. But on the other hand, if at the top of the stack there is some higher precedence operator and some lower precedence operator occur, then first we pop all those operators which have higher precedence from the current operator. We popped those and we put into the postfix expression, and then finally we put the lower precedence operator into the stack. In this example we can see that A star bracket left parenthesis B divisions C star D minus E right parenthesis, then plus F, then power G star H. We have to convert this expression to postfix expression. So initially we put left parenthesis in the stack. Then when A occurred, A will be kept in the postfix expression. Then star occur, star will be kept in the top of the stack. Then again left parenthesis occur, it will be pushed onto the stack. Then B will be kept in the postfix expression. Then division operator, so division operator will be kept at the top of the stack. Then C occurred, C will be kept in the postfix expression. Then star occur, star and division have same precedence, so star will be kept at the top of the stack. Then D encountered, D will be pushed on, D will be kept in the postfix expression. Then minus occurred. Now minus is having the lower precedence than star and division. So first we pop star and put it in the postfix expression. Then division, this also be popped and kept in postfix expression. And then we push minus sign onto the stack at the top. Then E occurred, E will be written in the postfix expression. Then right parenthesis occur. So when right parenthesis occur, then all those symbols one by one will be popped from the top until some left parenthesis occur. So minus will be popped and put on into the postfix expression. Now plus symbol occur. So division, multiplication is having the higher precedence than plus. So first we pop the multiplication symbol and put it into the postfix expression, and then plus sign will be pushed onto the stack. Then F encountered, F will be kept in the postfix expression. Then power symbol occur. Power is having the higher precedence than plus, so it will be kept onto the stack. Then G encountered, G will be kept in the postfix expression. Then star, now star is having the lower precedence than power. So first power will be popped from the stack and kept in the postfix expression. Then H encountered, H will be kept in the postfix expression. And finally right parenthesis, when right parenthesis occur, then this star and plus will be popped from one by one from the stack and kept in the postfix expression. So this is the final postfix expression: A B C D star slash E minus star F G arrow H star and plus. So this is how we can convert infix to postfix expression using stack. Now we will evaluate the postfix expression using stack. Here we are having a postfix expression 5, 6, 2, plus, star, 12, 4, division, minus. So in first column we will scan all the symbols which is given in the postfix expression, and in stack we put one by one symbol like this. So 5 encountered, it will be put onto the stack. Then 6, then 2, then when plus encountered, then we extract the top two symbols and perform the operation plus. So 6 plus 2 will be 8. Now star operation, star occurred, so 5 into 8 will be 5 into 8 operation will be performed, and result 40 will be pushed onto the stack. Now 12 occurred, 12 will be pushed at the top of the stack, then 4 occurred, 4 will be kept on the top of the stack, then division. When division encountered, then top 2 symbol will be extracted and this division operation will be performed. So 12 divided by 4 will give you 3. So 3 will be pushed onto the stack. Now finally minus symbol encountered. So 40 top 2 symbols extracted from the stack. So 40 minus 3, 37. So 37 is the results of this postfix expression. Now we will see the tower of Unai problem. So what is tower of Unai? It is a mathematical puzzle where we have 3 rods A, B and C and N discs. So in this mathematical puzzle there are some restrictions. We can extract only one disk at a time and put it onto the other tower. Tower A, tower B or tower C. Sometimes we call these tower begin, auxiliary and end. Our motive is to transfer all the disks in the same order from tower A to tower C or begin to end. So initially all the disks are stacked in decreasing value of diameter, that is the smallest disk is placed on the top and they are on the rod A. So we can transfer only one disk at a time and no bigger disk can be kept on a smaller disk. This is another restriction. So what we will do here is we transfer the first disk from tower A to tower C or begin to end. Then remaining end disk we will transfer from tower A to tower B. Now finally what we will do? We will transfer the remaining disk from tower A to tower C. This is the algorithm for tower of Unai problem. So if n equal to 1, if n equal to 1 means if we have only one disk to transfer, then we simply transfer begin to end. Begin is the first tower or tower A, auxiliary is the tower B, end is the tower C. So if we have only one disk, we simply transfer from begin to end. Otherwise, what we will do, we first transfer n minus 1 disk, top n minus 1 disk from tower A to tower auxiliary. So begin to auxiliary. Auxiliary will be the ending tower for this situation and end will be the and n will work as an auxiliary tower. Now the last disk, that is the biggest disk, will be transferred from begin to end. And finally the n minus 1 disk which we kept in the auxiliary tower in step 1 will be transferred from auxiliary to end, using begin as an auxiliary tower. So this is how we transfer end disk from tower A to tower B or tower begin to tower end. So this is disclaimer. All these content presented is based on the knowledge available up to the date of the lecture and may not reflect the most current development or advancement in the field. As new research and discoveries emerge, the information presented may become outdated. Therefore, it is essential to independently verify and consult authoritative source for the latest information. So these are some references: data structure, Shom series, data structure by Tenenbaum, and third book is data structure by Narasimha Karmanchi.